Hey everybody, my name is Justin Momo. I am a professional pharmacist and founder of Pharma Friend Justin. My motive is to make people more informative and spread awareness about whole virus or inactivated virus type COVID-19 vaccines. What are the COVID-19 vaccine types? There are four categories of vaccine in clinical trials. The four main types of COVID-19 vaccines are whole virus, viral vector, protein subunit, and nucleic acid RNA and DNA. Some of them try to smuggle the antigen into the body, others use the body's own cell to make the viral antigen. Whole virus or inactivated virus type COVID-19 vaccine. Many conventional vaccines use whole viruses to trigger an immune response. There are two main approaches. Live attenuated vaccine use a weakened form of the virus that can still replicate without causing illness. Inactivated vaccine uses virus whose genetic material has been destroyed so they cannot replicate but can still trigger an immune response. Both types use well-established technology and pathways for regulatory approval, but live attenuated one may risk causing a disease in people with weak immune system and often require a careful cold storage, making their use more challenging in low-resource countries. Inactivated virus vaccine can be given to people with compromised immune system but might also need a cold storage. What are the whole virus vaccines and how would they be used against COVID-19? All vaccines work by exposing the body to molecule from the targeted pathogen to trigger an immune response, but the method of exposure varies. Here how whole virus vaccines work. Whole virus vaccine use a weakened, attenuated or deactivated form of the pathogen that causes a disease to trigger protective immunity to it. There are two types of whole virus vaccines. Live attenuated vaccine use a weakened form of the virus which can still grow and replicate but does not cause illness. Inactivated vaccine contain virus whose genetic material has been destroyed by heat, chemical or radiation, so they cannot infect cells and replicate, but it can still trigger an immune response. Both are tried and tested vaccination strategies which forms the basis of many existing vaccines, including those for yellow fever and measles, live attenuated vaccines, or seasonal influenza and hepatitis A inactivated vaccines. Bacterial attenuated vaccines also exist, such as BCG vaccine for tuberculosis. Advantage and disadvantage of live attenuated vaccines. Well-established technology, strong immune response involve B cell and T cells, relatively simple to manufacture, unsuitable for person with compromised immune system, may trigger disease in very rare cases, relatively temperature sensitive, so careful storage necessary. Advantages and disadvantages of inactivated virus vaccines. Well-established technology, suitable for people with compromised immune systems, no live components, so no risk of the vaccine triggering diseases. Relatively simple to manufacture, relatively stable. Booster shots may be required. How do whole virus vaccine trigger immunity? Both live attenuated and inactivated vaccine contain the whole or a part of the disease causing pathogen, but the type of immunity they trigger is slightly different. Live attenuated vaccines are derived from the virus that have been weakened under laboratory conditions, so that when injected they will infect cells and replicate but cause no or only very mild diseases. They may be unsuitable for people with compromised immune systems, for example those with HIV and pregnant women, because even a weakened virus may trigger disease in this individual. Also, in very rare cases, live attenuated vaccine can revert to be more pathogenic form, triggering a disease in vaccinated individual or their contact. This have been seen for vaccine-derived polio virus associated with oral polio vaccine. Because these vaccines are simply weakened version of natural pathogens, the immune system responds as it would to any other cellular invader, mobilizing a range of defense against it, including killer T cells which identify and destroy infected cells, helper T cells which support antibody protection, and antibody producing B cell which target pathogen lurking anywhere in the body. For example, blood. This immune response continues until the virus is cleared from the body, mean there is a plenty of time for memory cells against the virus to develop. Because of this, live attenuated vaccine can trigger an immune response which is almost as good as being exposed to the wild virus but without feeling ill. Inactivated virus vaccines also contain the disease causing virus or part of it, but the genetic material has been destroyed. For this reason, they are considered safer and more stable than live attenuated vaccines. They can be given to the people with compromised immune system. Even though the genetic material has been destroyed, inactivated virus usually contain many proteins which the immune system can react to it, but they cannot infect cells. Inactivated vaccines only stimulate antibody-mediated response, and these responses may be weaker and less long-lived. To overcome this problem, the inactivated vaccines are often given alongside with adjuvants, agents that stimulate the immune system, and booster dose may be required. How easy are they to manufacture? Different viruses require slightly different production process, meaning separate equipment and facilities are needed for each one. For instance, the influenza virus is grown inside fertilized chicken eggs, which must themselves be sourced from specialized sterile laying facility. Polio virus is grown inside dishes of cells, which require different handling, while bacteria-based vaccines are grown in vast bioreactor. Growing live pathogens means stringent precaution must be taken to avoid the virus escaping and making vaccine plant workers sick. Once a large amount of virus or bacteria have been grown, they must be isolated, purified and attenuated or inactivated, depending on the virus. Each of these steps requires specific equipment, reagent and stringent procedure to avoid and check for contamination, which can further increase cost. That's all from me now, guys. I hope from this video you'd gain more knowledge, and if you like this video, please give me a thumbs up and please put a comment below this video what other video you'd like me to cover, so that I know what you're looking for. And please do share and subscribe to my channel for my friend Justin.